Welcome to solverfy.
So find the coefficient of friction between the block and the rough surface. If the block sliding with a velocity of v faces a spring and compresses it by 3.9 centimeters. So it basically means that initially the system has only kinetic energy of the block, which is mv squared over 2, shown here. But then after it compresses a spring, the overall energy is dissipated into the work of the friction force plus energy of the deformed spring. And here I write down it as an absolute value of the work of the friction force because it has a negative value. But we just need this form to balance the energies. Now we can calculate this absolute value of the work of the friction force, and it equals to mv squared over 2 minus k delta x squared over 2, which turns to be 18.5 joules. As we can see, this component is quite low in comparison with kinetic energy. Therefore, the block is mostly stopped due to the friction. Now let's calculate the coefficient of friction. The work of the friction force equals to friction force times delta x, which is mu n because it's horizontal, or mu mg times delta x. Now we can calculate mu, and it turns out to be really huge. So it's quite surprising that it's so much above 1. It's still physically realistically, because there are surfaces which can have such a high friction, and also it makes sense based on very short distance after which the block has stopped. And so basically, and also here the spring constant is not too high as well. So yeah, although this number seems to be a little bit surprising, it makes sense, and I double check the solution. So I don't think there is anything wrong with numbers. Thank you very much for your attention. I hope I helped you.